Today we will have two talks again, like last time. And our first speaker is Daniel Lachat from York University in Toronto. And he's going to be talking to us about wind trends in the far north, model-based climate projection.
Yes, thank you. It's not just me, of course. It's Rick Bello, Kazubuchi, and Monica Bisbani doing this project. And it's a work in progress, actually. I joined the party just 4 months ago, and so what I'm going to show here is not introduce new issues on this climate model topic, but to provide a case example and wrap up a couple of things I think we heard in the last speeches. The background actually is Hudson Bay coast, and as we can already see when I talk about winds in the far north, it's not the average 5 meters per second where you have to hold your hand. So it's a bit more severe than that. And we're also actually providing an impact analysis, and it's funded by the Ministry of Environment of Ontario. So we will have to answer very specific questions I will introduce later. And first, a little overview. Hudson Bay and James Bay Lowlands would be around here. This is Hudson Bay, this is James Bay. We are right now here in London, somewhere here. These are the Great Lake areas. And the morphology of the place is pretty much flat wetlands, so this is what it looks like up there. Most of the settlements are along the coastline. The biggest one would be Moosonee down here, and then there's Fort Albany, Attawapisquit, and so on. This green part here would be a provincial polar bear conservation park. I just mentioned these things because I will come back to every of them. And what we have seen, just from the scientific perspective, we have reduced sea ice cover in Hudson and James Bay for the past 30 years. We can tell so by satellite measurements. And we have also some indication of an increased wind up in the far north of Ontario, that is. And this was published in a paper by Yawadal just 2 years ago, but he was actually focusing on the south of Ontario and noticed decreasing wind speeds there in the same period, and he went into detailed analysis on that, but just stated the fact that wind speeds might be increasing in the north. So for us, that was reason enough to pick it up and look into it, what happened actually the last 30 years. And since there is no measurement stations, I have to go back to that, no measurement stations at all. So we have one here, we have one more inland, and we have Churchill up on Hudson Bay coast. But for this whole area, maybe a quarter the size of Europe, there is not a single measurement station existing. And also for the ones existing, there is not many parameters measured. And the time series are not very long. So we have a very unsatisfying situation, in my opinion. So the only way I have to go back to models. And what we did is we used this HadCM3 Regional Reanalysis, which was also mentioned yesterday, which is a reanalysis, so it's not a model prediction. What the model does is integrate all the available measurements and modeling them over a bigger domain. As we see here, this would be the NARR domain, and we take this extract again. And what we have a lot of input parameters, output parameters we can choose. We have wind, we have temperature, we have precipitation. And we have not only the wind speeds, but we have also the zonal and meridional component of wind. To me, that is very important because that allows not only statements on the magnitude of wind, but also on directional shifts. And when we come to harbor infrastructure and things like that, this is vital. So we can make these very nice plots. It has a resolution of 25 kilometers. This will be the means of October of this baseline period, 1980 to 2010. Of a meridional component. What we already can see is the wind is blowing stronger over water bodies than over land. And we can actually interfere a lot of this. We thought about what might be the conceptual causes of these increasing wind speeds, and we built up a working hypothesis of that. So we thought along the lines that the decreased sea ice cover of the last 30 years, since the water bodies are now ice-free, they release a lot of latent heat. And this latent heat would actually cause increased atmospheric instability, which would lead to, since there is an upward transfer of momentum, corresponding downward transfer of momentum from aloft due to momentum conservation, and that would increase the surface winds. To prove something like that conceptually, and this is also from the NARR data, they have data on albedo, That's the reflectivity of the surface. So of course, if the lake is ice covered, it has a very high albedo, and if it's ice free, it has a very low one. So we can use that as a measure for ice cover. And what we see here is actually mean wind speeds regressed, the trend in mean wind speeds regressed against winter seasonal mean albedo. And we see that the lower the albedo gets, there is a strong increase in wind trends in these regions. And to us, that is very interesting, and that might be a reason why this phenomenon will continue increasing in the future. So, coming back to the region, we see that, as we already stated, most of the settlements are along the coastline. The regional vulnerability is extremely high, and we have various impacts on wind speeds, and a lot of them are coming in feedback loops. For instance, wave heights. If we have bigger ice-free areas over Hudson Bay, we have a bigger fetch. So the wind blows over a bigger part of open water and is stronger in itself. So both of these effects result in bigger wave heights. And these big wave heights, they tend to have an impact on coast erosion, on damage of harbor infrastructure, on fishery, which is the basic trade, and on snow, the wind itself too, on snowdrift, on breakdown of infrastructure, especially on transmission lines. And we see that all these problems and impacts are on different spatial scales, and we need a very differential adaptation strategy here. So there is nothing like, in average over the whole Northern Ontario region, we have this and this climate change, so we would take and integrate this and this adaptation strategy. It might even differ from town to town a lot, as we can see the coast morphology of Hudson Bay is not oriented in the same way, so it might affect the settlement here because of the shift in wave direction. Might not have any effect down here in the Lowlands district, and adaptation strategies might be most urgent here, but not at all needed down there. So, as an example case, which we are actually working on right now, there is this very sad development that the communities living on this James Bay coastline, they usually, for heating, they use diesel generators. And this is quite pricey, and they thought it would be a good idea to replace that with and connect themselves to the power grid line down south in Moosonee. So they put down their money, to put their money together. They founded Five Nations Energy Corporation and built a transmission line which links Moosonee to the coastline. And this power transmission line is getting broken down every other winter. Quite famous in the last ice storm of Ontario last winter. They were without power for 13 days up there, which in minus 30 degrees in poorly insulated houses is a very vital observer. So it's nothing like, I'm not having a projection for what is going to happen in the next 50 years and should we adapt. It is very, very pressing. They want an answer this December when I go up to Moosonee and hold a presentation. Just to keep that in mind as a conceptual framework of responding. Now, of course, I have to go into the future. I have to model what will happen in the next 50, 60 years, and we have to do so as we've seen, on a regional scale. So what is needed is a regional climate model. So we use this PRECIS regional climate model that's generated by Wang at the University of Regina, and these are the purposes. 50-kilometer resolution. It's driven by the HadCM3 GCM, which we talked about yesterday, it was mentioned yesterday too. And it's actually a very good performing GCM for Canada too. It has been combined with a couple of RCMs. And we can choose output periods. We have a baseline period, 1960, and we have these three other periods. When I was asked, because for me as a climatologist, this must be a joke. So first I asked, how could you choose these periods? And I was told that these are the most common comparison periods in climatology. But of course, instead of choosing this overlap, I would rather have a bit more of the present day to validate. But this is just what we have. So going from there, you can then, this would be the domain chosen for analysis. You have this pixel by pixel analysis, where you can make nice maps. You can do trends in speed, trends in direction. You have seasonal trends, you have spatial trends. This, for example, would again be the northward component, the meridian component, an annual mean between 2050 and 2045. And then we can see which coastal regions might be most sensitive to stronger winds and so on and so forth. We can see a spatial pattern, we can see a lot of things, which I thought is fantastic. I already went back to Rick and I thought this is going to be a piece of cake, we can write up the report in a week. I mean, the level of detail of this regional climate model is astonishing, and it will make it easy actually to answer these questions. For example, we can take a point up here, this would be Cape Henrietta Maria, and we can make detailed windrows analysis. This is monthly wind speeds. This one will be the baseline period, and this would be 1965 to 95. We can see in which direction it adds up more. We can calculate the wind run, which is actually the sum of the wind blowing during the whole year. And we can see that the directionality is also increasing, so the directions are narrowing down, and the wind is getting stronger in one direction, but weaker in other directions. Which is also, of course, if we think of protectional infrastructure of harbors, a very vital thing to know. So I was euphoric about the level of detail we would give information, and then, of course, also on a seasonal scale. So we see here that this is the annual cycle, so to speak, of wind, and all for the 4 periods. And we also see that the increase in wind speeds over time is not homogeneous in season. So we have the most increases actually in the winter and spring seasons. And for what we observe now, actually, it's December and January wind speeds picking up most, as you can see the difference between the purple and the red bar, which is their biggest. But in the future that might change, and in the future might actually be the spring month picking up more, as this model suggests. And that is also an astonishing level of detail. And then we have the problem of model validation. I have to confirm that. I mean, I have this very precise information here, which I have to validate against something before I go up to Mussolini and give out recommendations. And as we heard, there is this adequacy for purpose. But now we have a variety of scales, and down to very local size. A harbor is on a grid size of 25 kilometers, is already at the limit, I'd say. So, and the wind itself poses difficulties because it has a strong seasonality, it is a very seasonal phenomenon, and it has a strong spatial gradient. So forget about averaging there. And so then again, for validation purposes, we can't refer to measurement stations and things, of course, but we can, as was suggested, when a climate model should at least be able to reproduce the past. So we can test that, and we can use PRECIS RCM and run it against NARR over the same domain and over this parameter. So we look about, and this was actually what's suggested a lot of time in this conference. We choose a specific region and a specific parameter and see if the model performs well there. And of course with some technical difficulties because the NARR is 32 kilometers, PRECIS is 25. We have only an 11-year overlap period of the models, but nothing we cannot solve straightforwardly. So, just as a quick overlook, we can choose a comparison strip. This would be 10 and 1 degrees up in the far north. Then this would be the PRECIS output, and this would be the NARR output. We can do so for, this is the mean of 11 years of July. And sorry about the color coding here, I might rather show this one, because it's the same color coding. This is for January. And we can see that, well, if we would mean this and compare the two numbers, they're not even that bad. Problem is more fine-scale resolution, as we can see that the spatial gradient is far more represented in the PRECIS model than is confirmed by NARR. So if we speak about a harbor here in the coastline, this is an important problem. Because as we see for this comparison period, this spatial gradient does not so much exist in NARR. It might not exist at all. And if I make future predictions, we will see then that the winds inland are actually decreasing or staying at the same level for pretty much a long time, up to 2050. Where on the coast they're increasing furiously. Now what do I make of that? How do I validate this spatial gradient? Another thing is in season. I have here NARR and PRECIS as monthly means during this comparison period, or averaged over the whole domain. So I'm trying to take the spatial gradient out and just look at the different seasons. And what we see is, generally the agreement is not that bad, and we have seasons where they are way out of control. There's no agreement here, and actually the fact that it's June and July is exactly the period when the sea ice breaks up and starts to disappear. So this might actually hint to physics in the model, which is correctly parameterized in NARR and not in PRECIS. Or vice versa, what do I know? So the problem here is that we have, let me summarize this a bit. From this regional climate model, we expect an added value. We think that if we can downscale to 25 kilometers, we have the spatial and the seasonal information. And how to validate? We have seasonal patterns, which are dependent on spatial patterns. This annual cycle I show you, this is the average for the whole strip. But if I would do this from east to west, from inland to coast, even this annual cycle is changing. So even the seasonality is a function of the spatial position. Now, if we have a model agreement that is good in some parts of the season and in some parts of the geographical area, what kind of information does that give me? I mean, we cannot average because that would not meet the adequacy requirements of the problems we have. And we can not only limit us to the seasons that the agreement is good and the region where the agreement is good, because the problems do not occur in these regions and in these seasons. So I see my hands are bound there a bit, and I actually see this added value of the regional climate model breaking together. And I see that in this case, we clearly see that the spatial and temporal dimension of the research problem we have, of the request of the stakeholder, that gives us the spatial and temporal adequacy the model prediction needs to reach, but also the temporal and spatial adequacy the validation has to perform. And as long as we can't validate this, I have a very hard time taking these very, very precise values of this model output and make policy recommendations out of them. And the same holds also true for the numerical adequacy. So I'm in a very comfortable position where I don't have to convince people that this change is happening and the winds are increasing. But then again, this poses very more precise questions about thresholds. And these are known, like we don't have the problem that we don't know the tolerance. We know the tolerance, we know how many meters per second it needs to break down a power transmission line, or how high the waves can be that it can still go out fishing. But this is very precise a limit. I can't come with a range of plus minus 5 meters per second. This is clearly of no information to them. And also, I cannot go in a gradual statement. I always hear from philosophers, they don't want to have it binary. Well, buying a diesel generator back and selling a power transmission line is a binary decision. You can't do so 30% gradually over the next 20 years. It is exactly a yes or no case. And of course the risk decision is by them, but what I provide, the information should provide a framework to decide that risk. And concluding just to stress that fact that time is ticking, you know. Of course, we can do detailed sensitivity analysis as was shown. We could see which regional climate model suits best. We can import them all and make a detailed model diagnostic and sensitivity study, and maybe in 3 years we have an answer. But I'm expecting to go up there, and this is the case right now. This picture was taken last winter, and the communities there don't have time for the necessary knowledge built up. So what I'm actually thinking right now is might have been better just to buy a research vessel and have cruised Hudson and James Bay for the last 3 years instead of doing this. And that's my question also here. So as I said already, I'm not going to end with conclusions. It's more a question to the audience. That would be that.
Great. Questions?
So what are you going to say in this meeting? What are you going to say in this meeting?
Yeah, that's a good question. That's a good question. For certain problems, especially considering the requests of the Ministry of Environment of Ontario, we do have answers because the problems are rather of general nature. General climate change in the far north we can characterize. There are luckily model agreements in space and season which allow us to address one or two of these questions. There is one harbor in Fort Albany which actually has a very nice agreement in space where we have a confidence. Then again, I'm not sure if this model agreement in space and time, if it's just for a certain space and time, actually has some meaning. This could be completely arbitrary. And also for these 10 years, I can't exclude that. And we were flabbergasted by these validation problems also, because as I saw in the speech yesterday, that was from NARR, from NCEP. That was to me that was the conclusion that when you analyze different regional climate models over different regions, and that actually the best model in one region from the same parameter can be the worst in another region is devastating. To me, I would actually conclude that there is no sense in even trying another regional climate model and compare. Yes.
My questions included exactly what you ended with, was what about doing the measurement stations? And that takes 3 years, you answered. So you can't do that before you go up to the...
That's true.
But the question, the bigger question is, if you take, say, 60 degrees north, or what's the latitude? Is it 60?
That was above 50. It's between 50 and 57 now.
Okay, if you run around the globe, are there analogs? Are there places in Russia? Are there places in Scandinavia? Are there places with measuring stations that are showing the wind speed increasing? And then the second half is a different question. It's that general assumption that equator to pole gradients are going to be decreasing, and so the global calming is going to get us, you know. And so there's a big macro theory that the Earth's winds might be calming down, based on there's even an old paper by Gates who wrote a paper called Global Calming back in the 70s.
Well, I think that both questions go around the same direction.
Okay.
So
the total, and then the other aspect of it is not just the local winds which you need for that harbor, but the kinetic energy of the whole latitude zone. Let's say.
Mm-hmm.
I guess I'm really thinking mostly about zonal winds right now.
Mm-hmm. Yeah. Yes. And in this case, it's actually the meridian ones which are interesting a little more because they bring the waves from that.
That's what I'm thinking.
But to compare is difficult because, of course, for general climatological reasons, we can't use Scandinavia because of the whole Gulf Stream influence and how temperatures and winter seasons and everything is completely different. In Russia, the regions we could use a lot, because the one phenomena here with the winds is actually this spatial pattern that we have large water bodies interacting with land masses. So Siberian measurements wouldn't be adequate. We need something close to, which also includes the phenomena that we need water bodies will have a decrease in sea ice. And because it's just a working hypothesis, but we suggest it is a cause. So, and besides, the Siberian measurement station coverage is not that much better. So you could not compare to a lot, so to speak. And what was the second part of the question?
This idea about global calming and
yes, and
assumption that
this might definitely be an overlaying effect in general, because this is a local phenomenon.
Right.
As we see, it doesn't even reach southern Ontario where the wind is decreasing. It's a problem with the wind power plants there. Nice suggestion to, also wind power plants could migrate upwards to meet the wind. And so there's also, and the problem might be the solution, speaking of the power line, maybe not buy the diesels back, maybe do wind power plants up there, since that might be promising.
Well, the precautionary thing might be just say that harden all your infrastructure and maybe have 2 energy sources instead of 1.
Oh, definitely a backup. That was the problem last winter. I mean, yeah. Oh,
that's our problem too in Maine. I think it was only 5 days for us.
Yeah, I heard so. So, policy advice in that case to me is very, very tricky.
So I have 2 questions.
Yes.
And they're both, I don't actually endorse them, it's just sort of playing devil's advocate. So, So don't think I'm actually.
Okay.
So the first question is, wind patterns are weird because they're so obviously spatially, like affected by spatial factors, as you showed us. So the question that came to me is, so why are you starting off from the global model in the first place? Is it because it's incredibly expensive and there's nothing else? Or is, you know, it seems like it's hindering the science more than it's helping as an outsider.
Well, I mean, I see this, yes, the winds are spatially very diverse and very complex, I see that point. But that might be also the distinction between weather and climate. If you average winds over 100 years, they're surprisingly consistent. So there is something like a mean wind. It's hard to say when it shifts, though.
That doesn't help you, right? That doesn't help you for policy.
Because it's the extreme wind.
Because it's the extreme wind that messes everything up.
Yes, but we can still see that like general storm patterns have a direction. That's where the harbor is usually enforced in that direction. If that direction would shift, the harbor would be vulnerable. So some of it, also the alignment of transmission lines could be chosen differently according to very general, and of course all of these are average winds. This has nothing to do with extremes. So this is actually a conservative estimate. When I say the winds are picking up, I'm talking about average winds picking up. I don't even want to know what the storm winds are doing.
I see. So we still have a couple of minutes, so if no one else is asking questions, I'm just going to continue asking questions. I was wondering what would happen if you sort of just said, look, people of there, we're very sorry, but we don't know. To do sort of
I will actually go along these lines. I mean, as a scientist, there is no bull talk. I will give a straight answer to, and which actually will be we are not capable of giving a straight answer. And it might be a little bit better, as we already discussed in the break, of flipping a coin, so I might think my answer might be a bit more adequate than 50%, but it might be only 60 or 65. And that is nothing you can base risk management on. I know, I see that point. But I don't want to make false statements here because this actually suggests a level of adequacy which is not there, if we look at these pixel plots. And there I really have a problem just because we have nothing else, that doesn't mean we have to use the model by all means. I find that a very dangerous stance, and I will not take that.
Yeah. Since they gauge wind speeds historically on property damage, or at least tornado speeds and hurricane speeds, is there any historical evidence of property damage that could give you at least a peak calibration?
That is extremely difficult because the property properties vary so much around the globe. Exactly these, there have been a lot of studies actually. You can imagine reinsurance companies, they do a big library of statistics about that. But for instance, you can't compare the Caribbean with the Netherlands and the
just in your area temporarily. No inventory. There is actually now an increasing interest since last winter of power companies to parameterize and forecast this ice storm event. And they would be happy to fund whoever would be crazy enough to try to parameterize that. There was a 98 event, I don't know if it got into that region, but the Great Ice Storm was 98. It's huge. Across on Quebec, right?
But see, the meteorological conditions who lead to an ice storm, these super cool droplets and whatever factors come together, is very, very hard to parameterize in a model. So to end up with an appropriate number of ice storms, and not an abundance or lack of them.
Well, in that case, I can't help out.
Sorry, one more question.
It seems like the message you need to actually give is that someone needs to put some weather stations in this area.
Yes.
Now, given that we're about to land something on a comet, you'd think that we're
Yes.
capable of putting a
And
few, like 10,000.
That is actually a very nice sum up of a fear I have, that since all these climate models exist, it's very hard to get resources for measurements.
Yeah.
And that I find a very, very sad thing, a very troubling thing.
Yeah.
Thank you for that notion, yes.
Because it's like you're saying in Siberia, you look at the map of weather stations across Russia and it follows the rail line. There's nothing north and there's nothing south.
Yeah. And also very, very sad is that a lot of long-term measurement stations are being closed down. I see this development in Europe, and I find this heartbreaking because these time series, they have a lot of value, but only if we continue them. And this is, yeah, exactly, that's a problem.
And on that note, we should thank our speaker.